Hey guys, welcome back to the channel. In our previous two videos, we actually solved this problem using two different methods. The first one was a top-down memorization approach, and this second one right here, which performed pretty well, was a bottom-up approach. Okay, this is the second one. I want to show you a third way. I call this the bottom-up swapping approach. Okay, swapping approach. So this is still a bottom-up, okay, but swapping. Okay, I'm gonna write that in there. Swapping approach. Okay, I like the word swapping. Okay, but anyways, in this case, we're gonna declare two variables first. I'm gonna call the first one 1 and the second one 2. You can call it A, B, C, whatever you want. Okay, I'm gonna set them equal to 1 and 1. Again, these are our two base cases, like we defined our base cases, two base cases, 1 and 1. Okay, so now I'm gonna say for I in range, okay, I want to go up to n minus 1. Okay, because we already have 2. Okay, and you'll see why in a second. Okay, so I want to create a temporary variable and set him equal to 2 for now, just to store the value of 2 in there. Okay, now I want to change the value of 2, so 2 is just going to be equal to 1 plus 2. This is the exact same as doing in the previous case, is doing a Fibonacci, is the Fibonacci of n minus 1 and plus n minus 2. Okay, that's all we're doing. We're just using some kind of buffer. Okay, then I'm gonna set 1 equal to 2. Okay, I'm just flipping them around. Okay, and in the end, I'm gonna return. It's pretty straightforward. Let's go ahead and run the code and see what's going on. Okay, accepted. Let's go ahead and submit it. Okay, it says we have the wrong answer. Oh, I'm sorry, because 2 has changed, right? We don't want to set him equal to 2 because we changed the value of 2 here. We want to set him to what 2 was before we change him, so we want to set it to temp. We want to set 1 to temp actually. Okay, let's try this now. Let's run it. Okay, let's submit it. Okay, now let's compare it to our bottom-up list approach. Okay, that's not it. Okay, so this was our bottom-up list approach. Okay, I gotta say this is a lot better than the swapping bottom-up method, but at least now you have 4 different methods to solve this problem. So now let's take it one step further. Okay, this is the first method we solved it, just climbing stairs 1, just a simple recursive method, right? Then we upgraded it because it timed out to a memoized version, right? We created a memoized version. Okay, let's go ahead and make it exactly as we did it before. Okay, so we're just gonna say memo of n equals n, and we're gonna return memo of n. Again, yeah, it's the same. Okay, then we memoized it. Okay, then we did a bottom-up approach using an array method, and we got this. And last but not the least, we did a beep swapping approach. So now let's time in and see who is the fastest. Okay, let's start with n equals 5. When n equals 5, okay, who is the fastest? Let's go ahead and run it. Okay, cool. So the first guy took 696 nanoseconds. Okay, not bad. Second guy is obviously the fastest, 116. Okay, so this guy is literally 5 times slower. So method 2 is 5 times faster than method 1. Okay, method 3, which is the bottom-up array, is the slowest, and this guy. So this is last. Method 3 was last. Second to last was method 1. Method 4 is third to the last, and method 2 is the best. Okay, so that's for this. Okay, let's go ahead and take a screenshot just so we can keep track of this. Okay, so now let's go ahead and upgrade n to 10. Let's double it and let's see what happens. Okay, bam, we're done. Let's compare it. Okay, so we doubled n from 5 to 10. So let's see what effect that did. So in terms of method 2 didn't even change at all. Okay, it's still the best. Method 1, let's see method 1. Method 1 is now 9 microseconds. Method 1 went from 600, I'll just call it 700 nano to 9 micro. So it performed terribly. Okay, it's now the worst. So the worst is method 1. The next worst is method 3. Okay, method 4 is the third. Okay, and method 2 is the best. Okay, so we can see as the input starts to scale, okay, the second approach pretty much almost stays constant because it has a logarithmic time complexity, while the others have more of a linear, or should I say even more, it's not linear actually, I think it's quadratic. time complexity. So which is why memorization number 2 is always the best. So that's for the video, guys. I'll see you in the next one.